Today we are going to talk about graphing inequalities. This is going to be a review of something you did in section 7.4, so you may want to pull out your notes as they may be helpful as we do our review today. So in this problem we have y is greater than x minus 8. Now I'm going to use the slope-intercept form to graph this. You could use the intercept form, or you could also create a table of values and plot the points from your table to graph your line. Now, here we have where x is 0, y would be negative 8. So we're going to go to our vertical axis, our y-axis, and we're going to go down 8 spots. And we're going to draw a point right there at negative 8. Now, again, I'm using the slope-intercept method, so I'm going to go look at my slope, which is in front of my x value, and it is going to be 1 over 1. Rise over run. So to calculate our slope, we're going to go up 1 on our vertical axis and to the right 1 on our horizontal axis, and we're going to go ahead and make another point there. Now, since this equation, this inequality rather, is greater than, y is greater than x minus 8, we're going to use a dotted line because the solutions on the line do not satisfy this inequality. So we've gone ahead and we've plotted our line. Now we need to shade. So we need to determine where we are going to want to shade. So I'm going to plug in 0 for my x and y. 0 is greater than 0 minus 8. 0 is greater than negative 8. So 0, 0 is a solution to our inequality. So we will shade this region all up in here. Now, what if we had a second inequality, such as this, where y is less than or equal to 5 minus x? Again, I'm going to use the slope-intercept method. So where x equals 0, our y is now 5. And we're going to go ahead and plot a point. And our slope in this case is still 1 over 1, but it's not positive 1 over 1. We have a negative sign there. So our rise here would be negative 1. So we would move down our vertical axis or our y-axis 1 spot, but we would still run to the right on the x-axis in the positive direction. So we would have a point here. Now that we have our 2 points, we can plot our line. But since this inequality is y is less than or equal to 5 minus x, we're going to use a solid line because we're going to go ahead and use a solid line because it's equal to. The solutions that fall on that line do satisfy the inequality. And I wanted to make sure our line remained blue here. And now I want to find out on which side of the line our solutions satisfy the inequality. So again, I'm going to choose 0, 0. So I'm going to plug in 0 is less than or equal to 5 minus 0. 0 is less than or equal to 5. So 0, 0 would satisfy this inequality. So I would now shade this region all in here. Now, if I were to take the inequality from the previous slide and this inequality and put them together, I would now have what's called a system of inequalities. And when you have a system of inequalities, you take each individual inequality and place them on the same graph, and where there's overlap, that would be your solutions for your system of inequalities. So here, the red and blue checked area would be all the solutions for our inequalities. Y is greater than x minus 8, and y is less than or equal to 5 minus x. One of the things I want us to realize, however, is that when you have a system of inequalities, solutions that worked for individual inequalities may no longer work for the system. For instance, if we were to look at the red inequality, where y is greater than x minus 8, and we were to have the point 6, 8, we would have a point that lays up here, and that would satisfy that inequality of y is greater than x minus 8. But as you can see, that coordinate point of 6, 8 does not satisfy the system of the inequalities because it does not fall in the red and blue checked area. Same goes for the point 6, negative 2. If we were to look at 6, negative 2 for the equation y is less than or equal to 5 minus x, we'd have a point that lays here right on our line. So that would be a solution to y is less than or equal to 5 minus x, but it would not be a solution to the entire system. One way of doing systems of inequalities is you can graph them together like this, or you can graph them separately like we did today and then put them together so that you can see where your solutions would lie and would overlap. So that is how we graph systems of inequalities. We use the skills from graphing inequalities, and we're just now combining that skill with 2 or more inequality statements.